just have a open proxy log. Yeah, sure. I got a proxy log on the right that just burp recorded. Here I'm just importing the GDS burp API. I'm just importing some the logging module just so that we could see some output as we do this. First thing I'm going to do is actually parse the burp log. It doesn't take much time at all, really. Then I'm just going to show off some properties inside a burp object. We have the full properties of what burp recorded. You want to call a method like get request headers on a certain object, get that. You could call it an individual header. So we have a documented API for this. So here now I'm just going to actually fuzz all my requests. And each request gets, each fuzz request gets actually appended to a replayed list for every individual burp object. So I could then call like the fifth element in the replayed list, the response headers that were fuzzed. Here I'm just doing like a diffing the responses of all the requests. And this is just shows easily, just visually why it's changed. Right there I'm just highlighting a script alert tag got inserted into the body compared to the original request. This one here, there was a set cookie header on a or 1 = 1 in a password field, and there was an actual redirect in the response. So that's a win, I think. So it's really a lot of cool things you could do with just a couple lines of code using the API. Another thing I implemented was a save state feature, which allows you to save all this data to just a single file. So then you could then later reopen it and have access to all those properties and values in your scanned requests.
You just showed saving and reloading state, right?
Right. So here I'm just accessing the just a replayed request and just getting response headers again, just to show.
So this is in the zip file too. Actually, I probably have that open. So just really quick, there's the docs portal on, it's just hexec.com/docs, like the updated presentation, because the one that's on your conference materials, like everybody else's, it's like horribly out of date and probably not even remotely the same. So you can grab the docs and the constricting code snippets as of right now. So hexec.com/docs and should point you right to it. But we did that like literally minutes before, so there's like no descriptive information on there. Okay.
So like I said, you can save state, load state. Parsing logs is about like a minute per 100 megabytes, depending on how fast your machine is. It's relatively fast, so if you find ways to make it faster, I'm all ears. I'm all performance here, not security. So that's the way I work when it comes to like doing burp stuff. So, you know, if you want it, take it. If not, you know, you can do other things. So it's all you guys.
Yeah, I love how black and white that is. If you want it, take it. If you don't, whatever.
So
I love how that picture was just taken with me going. I look like, it's like, what is he talking about? It must be really interesting. Another thing that's useful too when you're testing web applications is, since the browser is what renders all this stuff, it's nice to be able to integrate into the browser. How many people knew you could write extensions for Firefox in Python? A couple people. Okay,
5,
very good.
6.
How many people have ever done it? Is that
3.
another one of those punch your face things after you're done? It can be a little difficult. One of the reasons why I quit doing it, because I had written a couple of standalone Zool runner applications, I didn't have enough access to the browser object without having to resort back to JavaScript. So it was extremely difficult to say, you know, httplib2 or urllib2, go grab me some HTML, and I want to render it in this browser object. Because Mozilla has all these funky things with Chrome. So obviously it doesn't let you just grab files from anywhere, even though you're running in Chrome. So I got really frustrated with that quick, because I want to build, you know, tools. So what I started to do more of was like WebKit development using PyQt. With WebKit, you can use a web view and set HTML from another lib. The reason you'd want to do that, obviously, is because we're testing stuff. So we want to make sure that we have control over every single part of the request. Because just like he said earlier, you know, a lot of times tools don't give you enough context around what you're doing. So by writing your own client, obviously, you have all the context you need and you have all the visibility. So here's a couple lines of code in PyQt to instantiate a web view. Does anybody want to tell me what this web view does? I was just seeing it.
It's pretty easy.
Yeah. I was just waiting for an answer. This is audience participation, man. You're supposed to speak up. So some things like testing for cross-site scripting are a little easier to do from a web perspective rather than just seeing it, you know, in code and say, hey, did this get echoed back to me? So that's just one instance of, you know, exploiting a cross-site scripting vuln with this. But you can make a request with any lib you want to and render it. You might have a bunch of saved requests in like a SQLite database or something. And you might have like show HTML source in one pane and then render it in another pane. I mean, that's pretty common. So as you can see, you can do that in just a couple lines of code. It's basic. Some other things you can do. WebKit's getting a little more interesting on like the PyQt front. You can instantiate an inspector on an object, which is kind of cool if you want to like view into like the HTML source and see all the syntax highlighted stuff. But they're also allowing more access to Python inside the browser object itself, which is cool when you start looking at plugins like Silverlight and Flash and all that. So it's coming along. This support's getting much better for it every day. So that's going to be definitely a place to watch. SOAP-based web services are still out there. I mean, we still run into them all the time. One of the things that I've noticed is that there's really no good tools for testing SOAP-based web services. So there's a lot of vuln scanning companies who tout their web services testing. But has anybody ever like peered inside, other than the people that work for the scanning vendors that are here? Has anybody ever like peered inside the logic for scanning web services, see what it's actually doing? Probably not. I mean, I don't think many of us do. But what you can do with like suds, which is a module for Python, is you can create an object out of a WSDL and then start calling functions out of that very easily. So since it has an object API, it makes it very easy to call its methods. It uses, go back one. It uses URLlib2 for opener support. So since it's using URLlib2 underneath, that means it supports proxies, it supports different types of auth, supports, you know, all the things that URLlib2 supports. And it supports basic auth like right out of the box. So if you specify username and password, it's going to submit that.
That's a finding, right? Basic auth.
Yeah, it should be a finding, yes. So to read and print the content from a WSDL is easy. It's 2 lines of code. And to perform functions based on the WSDL there, that goes out and converts some currency. So let's do something a little more realistic. So here, what we did is we pointed it to a WSDL that we wanted to test. We created our custom transport because we want to handle everything out of the request, right? So we decided to set our own user agent, our own cookies, and our own basic auth token from a previous request. We installed the opener, and then we started to send our values. So this would be a lot better. Oh, okay, so there's no line continuation on here, but the SQL vals equals that's coming from the PyWebFuzz project, the imported FuzzDB. So that's why it's like gnarly and long. But so what this will do is it'll iterate over the top of that, calling the get credit card service, and run through those tests. And when you run that, what you see is a lot of responses. But you can see how some of them actually brought back data instead of none. Those are credit card numbers, so that's probably not good. Luckily, that was WebGoat and not my bank. Although it could be my bank and I just don't know about it. They don't let me poke around there.
So working with Flex, Flex is a framework for developers to develop web applications on top of the Flash platform. One of the features of Flex is being able to serialize messages into the AMF format. It's just some compact binary format. It's the action message format. Several tools out there support AMF. Tools like Burp, Charles, WebScarab. It's great. However, the downside to these tools is that I found is you can't really craft messages from scratch, and you can't add properties to AMF messages. So one of the modules out there available for Python is PyAMF. It has the AMF encoders and decoders that allow you to serialize Python types into action message format. So take, for example, like a Python datetime object. That'll get serialized into an AMF datetime, which then, when BlazeDS, the remoting server, receives that, it'll decode it into like a Java util.date object. With PyAMF, we can write clients and remoting gateways. Django and Twisted have support, so you can actually write Python web applications that serialize content to AMF. So if you remember from last DEF CON, one of my buddies, John Rose, wrote a tool called dblaze. It went ahead and enumerated remoting methods and services on a Flex remoting server, one at a time, just by brute force. One of the things that I noticed diving into Flex is an AMF envelope can contain multiple AMF requests. So I just thought, like, hey, why not just stuff all those AMF requests in one? And I could just do all that enumeration in just one HTTP request. So that's one of the cool things I did, as well as like assess the entire Flex app in one one HTTP request. So you could fuzz the entire app. Hopefully it doesn't break halfway through your requests. But it's one of the things you could do really easily with a couple lines of Python. You might run into, you probably will run into cases where the Flex client is actually passing back custom objects to the server. So like, say you have some employee object. When your proxy goes to actually try to deserialize this, it's going to choke on it because it doesn't know the structure of that object. So what we could do in literally 4 lines of Python is create an object factory. And this object factory is just basically a dictionary behind it. And then we just register that class with an alias, a class name alias, so that when PyAMF goes to encode or decode that object into an AMF stream, it encodes it as, say, that employee object versus just some dictionary. So that when the server then gets it, it knows that it's an employee object and not a dictionary or a hash map or whatever, and it works. So that's that.
Has anybody in here ever done any IronPython? Ah, I stumped you. How many people know what IronPython is? Okay, I didn't stump you. IronPython has tight integration into .NET. And there's a couple of cool things you can do for it. Obviously, we didn't have enough time to like go into all this, but it can be your friend when you're doing .NET stuff. Basically, you can import the common language runtime from .NET and then start calling functions out of the common language runtime, just standard .NET functions in Python, as well as be able to take .NET DLLs and call functions out of those as well. So if you're doing like Silverlight, if maybe you're assessing a Silverlight app, you can pull right through those. If you've ever heard of .NET Reflector, I mean that's using like a lot of the .NET reflection libraries. You have the same amount of access to the, well, I shouldn't say exact same, but you have pretty much the same amount of